Now let's look at law of cosines with SAS triangles. So first of all, let's think about what we mean when we say SAS triangles. The key to an SAS triangle is you know the angle that's in between the two sides. So here's an example drawing. If you knew that this angle was 51 degrees, this side was 17, and this one was 13, you would know a side, an angle, and a side, and the angle that you know is in between the two sides. And in that case, what you do is you can solve this using the law of cosines. So for notation, we're going to use A, B, and C, and we're going to use capital letters for the angles, and to denote sides we're going to use lowercase letters in such a way that if it's a lowercase a, that means it's the side opposite angle A, and if it's a lowercase b, then it's the side opposite angle B, and if it's a lowercase c, it's the side that's opposite angle C. So for an example, let's say that you were given that side B was 15 and side C was 12 and angle A was 37 degrees. We can draw that 37 degrees. This is side A, which you don't know. This is a side, and this is a side. And the law of cosines has three forms. A squared is equal to B squared plus C squared minus 2BC cosine big A. B squared is equal to A squared plus C squared minus 2AC cosine B. And C squared is equal to A squared plus B squared minus 2AB cosine big C. Sometimes what people do is so that since it's hard to distinguish between the little c and the big C, then they put a little cent sign through this. There's no reason to do that other than just realizing that you're talking about the side C rather than the angle C. So this is the law of cosines. You could always use it with SAS triangles and also SSS triangles. In this particular case, if we need to solve for, say, side A here, we look at these three and we figure out which formula works the best. Since we're given the angle A, large A, it makes sense to use the formula with that angle in it. So these three, I'm going to use this right here, and then let's step through a problem. So you have A squared is equal to B squared plus C squared minus 2BC cosine A. Let's plug in everything we know. In this case, we know that B is 15. We know that C is 12. Then we go 215 times 12 cosine 37 degrees. And at this point, if you notice, we have only in the whole equation one unknown, A, and we simply solve for that. And be very careful at the order of operations, PEMDAS, that's where most people make their mistake. 15 squared, let's see what that is. That's 225. Plus 12 squared is 144, I remember that. This is 2 times 15, that's 30. 30 times 12, plug that in the calculator, but 30 times 12 is just 360. Cosine 37. Let's add these two together. That's 9, 6, that's 369 minus 360 cosine 37. Now be careful right here. If we write right here, we can't subtract the 369 and the 360 because these are multiplied together, and you always have to do multiplication first. So it's 360 times cosine 37. That's 287.5 roughly. A squared is approximately equal to that. So you have 369 minus your answer, and you get 81.5 roughly. Take the square root of that. You get around 9. And oftentimes you can look at your answer and see if that's approximately right. It is in that case. That's how you find angle A. I'm sorry, side A. Now if you go back to the original problem, we now know A is about 9.07. We still might need to know the other two angles. In that case, what you can do is you can just use another formula. Let's say, for example, we want to find angle B here. Let's look at the formula for B. See if that can help us. What you have to do is you have to figure out whether or not you have all the information that you need. In other words, you have to know everything except for one thing. Here, we know what B is. We know what A is. We know what C is. AC. The only thing we don't know is angle B, so that's fine. So at this point, all we do is we plug in the numbers. We have B squared is equal to A squared plus C squared minus 2AC cosine B. If you plug in the numbers, you know from the original problem that B is 15. You know that A is 9.07. You know that from the previous step in the problem. You know that C is 12. That's given. Minus 2 times 9.07 times 12 cosine B. And this is what you don't know right here. So that's what you're going to have to isolate. Get a lot of calculator to work. I think I remember that 15 squared is 225. I should use an approximation sign because that's actually an approximation there. That's around 82.3. That's 144. Let's see what this is. That's 9.07 times 12 times 2. And that's about 217.7. And then cosine B. I'm going to add those two together. That's 226 roughly. Let's try that again, make sure I did that right. $226.3. And be careful here. You might be tempted to subtract this, but you can't because this is multiplied here. So what you've got to do is you've got to isolate the cosine B, but you've got to use the order of operations. So I'm going to subtract 226.3. And I get minus 1.3. Is equal to minus 217.7 cosine B. Divide. So cosine B is approximately, that's going to be a small number. .005, I think. Look at the cosine of that. I'm going to do cosine inverse of that number. I get about 90 degrees. And that's how you do the law of cosines, at least when it's SAS.